Good morning friends. In last play we have seen the equation regarding the period of simple pendulum, that is the t is equal to 2 pi under root L upon g, that is the equation for the period of simple pendulum which we have derived, and also we have discussed about the second pendulum. Today we are going to see the distinguishing point between the conical pendulum and simple pendulum. Friends, you have seen the conical pendulum's equation in the topic first, that is the rotational dynamics. Now we are going to distinguish between the conical pendulum and the simple pendulum. So before studying to the distinguishing point, I am going to draw the diagram so that you can get the idea. In the conical pendulum, the simple pendulum will perform the horizontal circle so this is the diagram for conical pendulum. And this is the diagram for the simple pendulum, which we have discussed in the last article. So this is the conical pendulum diagram and this is the simple pendulum diagram, so that it will be very easier for us to make the distinguishing point. So in order to make the note properly, I have written these points on the boards. First point, regarding the conical pendulum, the trajectory and the plane of motion of the bob is a horizontal circle. You can observe that the bob is performing the horizontal motion. So here, trajectory and the plane of the motion of the bob is a horizontal circle. So horizontal circle is the important word here. Now if we observe about simple pendulum, the trajectory and the plane of motion of the bob is a part of a vertical circle. If we are performing the vertical circular motion, then it will be just like the part of the vertical circular motion. So this is the important word, vertical circle. So trajectory and the plane of motion of the bob is a part of vertical circle. So here horizontal circle and vertical circle. If somebody have very difficulty in writing this, then he can write the small word like the path of the conical pendulum is just like as a horizontal circle, and the path of a simple pendulum is just like as a vertical circle. In the simple words also you can distinguish. That is the first point. Second point, kinetic energy and GPE, means gravitational potential energy, are constant. Here is no change. Once you have got the energy, that will remain constant. But in the simple pendulum, kinetic energy and potential energy are interconvertible. And if you remember, we have plotted the graph of the energy curve. So at the mean position, we have said about what is the position of the kinetic energy. At the extreme position, what is the position of the potential energy that we have studied. So remember, kinetic energy and the potential energy are interconvertible in the simple pendulum, but the total energy will always remain constant. It means if the kinetic energy increases, potential energy decreases, but the total energy will remain constant. So what is the point? Second point says the kinetic energy and the gravitational potential energy are constant in the conical pendulum, while in the simple pendulum, kinetic energy and potential energy are interconvertible. Third point is regarding the period. So the formula for the period of the conical pendulum is t is equals to 2 pi under root L cos theta upon g. And here the period of the simple pendulum has the formula t is equals to 2 pi under root L upon g. In both the equation, you can find one similarity, that both the period are independent on the mass. Fourth point, we can say the string can never be horizontal. You can observe that it is performing in this way. It will never reach to the top, means it will never reach at the horizontal level. But if we have a simple pendulum, if the large amplitude is here, then it may reach at the horizontal level. So with the large amplitude, the string can be horizontal. Again, I am going to explain the fourth point. In conical pendulum, the string can never reach to the horizontal position, but in the simple pendulum with the large amplitude, there is a possibility that the string may reach to the horizontal position. So these are the distinguishing points regarding with the conical pendulum and the simple pendulum. So friends, these points you can remember with the help of the diagram, so that it will be very easier to remember the points. Friends, next point which of the topic which we are going to see is the laws of simple pendulum. Laws of simple pendulum. Laws of simple pendulum. Friends, the total laws we can remember with the help of the formula T is equals to 2 pi under root L upon G. This is the formula for the period of simple pendulum. Here we are going to see law of length. Law of length, it means we should obtain the relation between the period and the length of the simple pendulum. So if you observe this equation, you can get the clear idea that the period of simple pendulum is directly proportional to the square root of length of the simple pendulum. So this is known as the law of length. Friends, again I am going to explain the law of length. I am writing only in symbolical format. You should have to write the total sentences while making the notes. So what you should write regarding the law of length of simple pendulum? That the period of simple pendulum is directly proportional to square root of length of simple pendulum. So this is the law of length. Second is the law of acceleration due to gravity. Law of acceleration due to gravity. So here we should obtain the relation between the T and the acceleration due to gravity. So what is the relation? T inversely proportional to square root of G. So you have to make the sentence regarding the law of acceleration due to gravity, that the period of simple pendulum is inversely proportional to square root of acceleration due to gravity. Again I am going to repeat the sentence, that the period of simple pendulum is inversely proportional to square root of acceleration due to gravity. So this is the law of acceleration due to gravity. Third is the law of mass. If you observe the equation, there is a no term of the mass, so m is not present there. So regarding the law of mass, we have to write the sentence that the period of simple pendulum is independent on the mass of the simple pendulum. Independent on the mass of simple pendulum. So this is the law of mass. Next is the law of isochronous. ISCHRONOUS. Law of isochronous. And friends, here isochronous is related with the term amplitude. So here you can observe that the amplitude is not present. So it is independent on amplitude. So based on this, we can make the sentence that the period of simple pendulum is independent on the amplitude. So these are the four laws which are known as the laws of simple pendulum. Friends, again I am going to explain these four laws. First is the law of length. The statement is the period of simple pendulum is directly proportional to square root of length of the simple pendulum. Second is the law of acceleration due to gravity. This says that the period of simple pendulum is inversely proportional to square root of acceleration due to gravity. Third is known as the law of mass. Here we have write the period of simple pendulum is independent on the mass of the simple pendulum. Next is the law of isochronous. It states that the period of simple pendulum is independent on the amplitude of the simple pendulum. So this is the part regarding the laws of simple pendulum. So in the examination, if it is asked write the laws of simple pendulum, then you should write the total 4 laws. In the examination, if the question is asked write the law of length, law of acceleration due to gravity, then only that statement you have write. So as per the question, you should try to write the answer. So friends, I hope you have understood the part. Today we have seen the distinguishing point regarding the conical pendulum and the simple pendulum. After that, we have also studied about the laws of simple pendulum. So make the notes properly. Thank you. Have a nice day.